Alrighty, in this video, what we're going to do is work on the bidirectional communication between our region server and our master server. And by bidirectional communication, what I'm referring to is the ability to pass in a deferred both ways. So right now, the way our systems are built, you can only have a deferred return type on systems that are attached to the server. So for example, if we looked at our base components, and went into systems master. So in our game lobby system, for example, we have a bunch of these deferreds, meaning that it's something that will return a response when the server receives and processes that remote procedure call. But we don't have any code in place that will handle that on the client. So right now there's no way for the server to say to the client, hey, do this thing and tell me when you're done. Now there are not a lot of instances where I would probably do that. I guess what I'm saying, because I think that that opens up a lot of complexity on the client side, and potentially could even now that I think about it, it could even be an attack vector, a denial of service attack, where if the client returned a deferred, right, and the server called this method, the server has to keep track of all the in-flight requests until the client, so that the client can respond to it. But what if the client gets this message but never is coded by an attacker to not return that acknowledgement? And if he does that, and does that enough times, causing the server to trigger all of these deferred operations being queued up, that could potentially lead to a denial of service attack, and would require additional infrastructure to take care of. Maybe something like a timeout saying, hey, if the client hasn't responded in 1 second, we're just going to reject this entire thing and clear out of memory. But that's just additional infrastructure that we'd have to put in place to keep that open. I'm just thinking about all the potential issues that would come with allowing this. However, getting away from the client-server communication and coming back to the server-to-server communication, I think that it is going to be very important for both the region server and the master server to be able to send deferred requests to each other. So what I'm going to do is I'm going to start with the iGame instance master. I'm going to go ahead and write a new method on this interface, and just going to be a test, and it'll be deferred def test or something like that. And with def test in place, we'll now get an error in our BuzzMMO server master. So jump over into systems.region, because we now need to implement that method here on our game instance system. So our def test, what I'm going to do here is, I don't know, context. Do we have access to a fiber application? We don't have access to any fiber here. You know what? I am going to go ahead. I'll just go ahead and create a fiber in this guy. So private read only iFiber fiber, and then we'll do a constructor. Remember, unlike mono behaviors, we can have constructors in our systems, systems on the server side. Fiber equals new. Let's just do a pool fiber. I don't really, or no, a thread fiber. I don't really care. And then we'll do fiber.start. And then, of course, down here at the bottom, I'm going to overload dispose. And does base.dispose do anything? No, it doesn't. Okay, I'm going to overload dispose, and I'm going to say fiber.dispose. Okay, so our fiber is going to be used in our def test method. What I'm going to do here is, let's see. I'm just going to make this easy. Var def equals new deferred, return def, and then fiber dot schedule. And I'll schedule an action in, how about 2 seconds, and I'll say def resolve. Or def set, do I have any helpers for set result? I don't think I do. I think it's just set result. So set result, true, null. Okay. So basically we just are going to say when the region server tries to hit this, we'll wait 2 seconds, and then we will set the result to true. So let's go ahead and test this on our region server, because I have a feeling this is actually going to work without any code changes. So let's jump over here to our systems.master. And on Pong, I'm going to go ahead and say proxy.deftest, and then on, how about just on always log info Actually, I kind of want to make this a little bit more interesting. Forgive me. I want to go ahead and inside of my... let me go ahead and go full screen to get some more screen space out of this. In my system, my game instance system... Whoops. No. In this game instance, I'm going to make this a deferred of... How about string? So it returns a result. That just makes it slightly more interesting, so we're also testing the ability to send data back in addition to sending whether or not the operation succeeded or failed. So, with that in place, let's go ahead and jump into... let's fix our game instance system on the master server first. So, of course, this is going to be in our BuzzMMO server master systems region game instance system. For this def test, you'll now return a deferred of string. We'll return a deferred of string, and then for the set result, I'm going to say true, null, and then for the result, I'm going to say hello from master server. There we go. So now I'm also passing in that data. Okay, so now jumping over into our server region systems master game instance system, I can now do an on always that takes in the deferred, so I can receive the result. So I'll say got def dot result from master server. So I have a feeling this is going to work. So I'm just going to go ahead and hit F6, wait for the build to start. Then I'll bring my logs down here so you guys can see it. Let's give it a sec. It's taking a little bit. Okay, so we restarted ping, and ping, two pings, remember we have 2 region servers, and then got hello from master, and it looks like we only got one of those. Again, I'm wondering if there's some sort of log file contention, lock contention going on here as to why we're only receiving information. This is a mess. All right, let's clear that out. Let's add 1, 2, 3 to make sure that we do get a new build. Let's hit F6. This should restart the game server. It should not restart the master server. Connect to master server, awoken, and there we go. After 2 seconds, got hello. Okay, so it is working. It's just there's some weird file contention going on here, I think, when they both try to write to it at the same time. I think that's what's happening here. But as you see in this particular scenario, it works. So we now know that the region server can send a request to the master server and return a result, but we won't be able to do it the other way around yet. And let's go ahead and get a test in there first. So I'm going to jump over here, and for our game instance region, I'll do deferred string, and I'll say region def test. I know I should be using unit testing here. I haven't been unit testing a whole lot of things lately in the last couple of videos, or many videos, mostly due to time and the fact that a lot of this is going to be refactored later, but it's going to be refactored in a way that'll still work for whatever we build on top of it. But again, I've already told you guys that I'm really planning on refactoring the systems infrastructure at some point. But I kind of want to get more use cases out first to figure out how what the best way to do that is. Anyway, so our region server now has a deferred member on it. So let's go ahead and implement our region server first. All it's a matter of doing is creating this method, and I'm just going to do basically the exact same thing we did with the master server. We're going to do a private read-only fiber, and then a constructor where I initialize this new thread fiber. Again, I despise field initializers. I don't know if I've mentioned that before, but yeah, I really don't like them. Anyway, so down here, I'm going to override dispose. Make sure to always dispose your fibers. If you do not dispose your fibers, bad things will happen. So with that in place, let's go ahead and say var def equals new deferred of string, and then return def, and then fiber schedule in 2 seconds def dot set result true null from region server, or from game server, or whatever you want to do. Okay, so before we compile, take a look at that code. Let's go ahead and actually invoke this from the master. So let's come back over here to the master server. How about after we send the result back to the region server, we then do proxy.region_def test, and then on always, and I'll say log info got. Oops, I need to capture the deferred variable or parameter, or how about result? The deferred result from the in the argument list from region server, and we run this, and we will most likely get an exception. Either we'll get an exception or nothing is going to happen. So we connected, and we got an exception. So there we go. This exception will give us the roadmap for implementing this behavior. So let's look at that exception. We got a, well, that was quick. It's right there. We're throwing a not implemented exception when we intercept a method that takes in a deferred. Okay, so the problem is remember inside of our client systems in the server, we have this proxy object. Remember? So the this interceptor where our generated interfaces or generated proxy objects go and invoke into, and has two overloads. When we intercept a method that doesn't return anything, we just do that. Or we can intercept a method that does have a deferred. And so this deferred, let's see. This deferred, if you recall, is the deferred that's passed in that is returned right here. So the proxy, the region def test, its deferred is going to be the deferred that's passed in here. So in order to resolve that deferred, we do deferred, and then we do set result, right? And so yeah, what I want to do first is I want to take a look at the analog for the client here. So in our client systems, we should have an analog, and we do the proxy interceptor, which for some reason is named differently. And what he does is he does operation invoke deferred, passing in the deferred. Okay, what does he do? He goes ahead and sends an operation with a particular... sends the operation to a component ID with the parameters, and then when the operation is done, it resolves the deferred by using the deferred.load method. So the send operation, of course, goes in, and let's look at the send operation of the, because remember we have two iClient transports, the iClient transport on the actual client, the game client, and the iClient transport implementation that's on the master server peer. So let's look at that one. And you see on this guy, what he does is he registers a callback, registering a callback, increments that ID, and all that fun stuff. So basically, we kind of have to create an analog of this method and of this well, the responses are handled by the system's event reader. We need to create an analog of that on the server, and this is another interesting case where I think what I'm going to do is just throw code at the wall, because we do have to get moving on at some point, and I'm going to make a mental note of how this code works so we can start merging these two different things, the client systems and the server client systems. But stuff and things, let's go ahead and think about how we can do it, because we have some limitations here. Basically, in our server master, or our server rather, in his client systems, when he intercepts a method, he needs to send the data to the transport, the underlying transport, the connection, but in a way that indicates which request ID this is and all that fun stuff. So as you see right here, the iServer transport simply has the send data method, which sends an event in the send operation response. So we need to send the data as an event, because we can't send an operation request. Remember, on the clients send operation requests in Photon, and servers send events. But you can't send an operation request to a Photon peer at all. It's just not possible to do. And unfortunately, our underlying, our peer, for our region server, our game servers, is simply a Photon peer. So we can only send events to it. So we need to send a special event that will indicate that we want a response back and also give it an ID. What I'm going to do is I'm going to, for the iServer transport, what I'm going to do is I'm going to do something similar to what we did in the iClient transport. Because if you recall, iClient transport has these two send operations. One that takes in just an operation code and parameters, and another one that takes both of those, but also a callback that returns an operation code and a dictionary. So we need to be able to send an operation code to the client that indicates... All right, let's just start writing code and see what happens. Okay, so I'm going to say void send operation. I'm going to call it an operation. And he's going to take in... Do I want to reuse operation codes? Well, no. Operation response code. No, send operation... This gets tricky. Because we need to send it through events, which are event code, sync system component map, add system, remove system, invoke method on system. Okay, we'll do send, how about this? Send event with response, event code, dictionary of byte and object, parameters, and then an action, just like what we did before, an action in our client transport, an action that takes in an operation code and a dictionary of byte and object. So I just copied that over, and we'll do this on, what did I call that? On response. All right, so code's a little messy right here. Let's go ahead and... It's a very long method signature with all those generic parameters, or generic arguments, rather. So now we have this send event with response method, which will act very, very similarly to the send operation with response method. The difference is that it will use an event to do that. Okay. So with that out of the way, for the iServer transport, we should be actually getting some errors here. We have 2 errors in 2 files. Our MMO peer base is an iServer transport, and our in-memory transport is an iServer transport. So the in-memory transport is in our test project. So go ahead and jump in. If you followed along with the test, you'll go into, I think, end-to-end in-memory transport. I'm going to go ahead and just hit Alt-Enter, and I'm going to leave it as throwing and not implemented exception. So, so at the very least, our code will compile, but at the moment, we won't be able to test that particular thing. Now, for our peer base on the iServer transport, the send event with response, that's going to get a little... It's going to get a little messy. So remember, the MMO peer base inherits from peer base from Photon and implements the iServer transport. I think what I'm going to do is I'm going to mostly implement it in the exact same manner that our peer in our client is implemented. So if we jump into here, into infrastructure, we should have a Photon client transport. We have, in our client transport base, we have this callback byte map already. And I think, yeah, I'm going to use this. All right, so let's go ahead and take this guy and jump back into our MMO peer base. Because remember, we need to keep track of all of the callbacks that we've initiated so that when we get a response, we can invoke the proper deferred. So we're going to do a callback byte map that takes an operation code and a dictionary byte of object called callbacks, and I'll go ahead and instantiate that. To instantiate that, I'm just going to copy and paste this because for some reason, ReSharper is not autofilling in my generic type arguments, and I'm not entirely sure why, but it's very annoying. Anyway, with our callbacks, now I'm going to come down here to our send event with response, and I'm going to take another bit out of the book here of the client transport base. We add the system invoke ID and then we send the operation. So what I'm going to do here is I'm going to do parameters at cast a byte, but this is an event. So I'm going to do event code parameter dot system invoke ID equals callbacks register callback, and I'm going to register a callback for on response. Then I'm going to send the event. So send event, which takes in an iEvent data and send parameters. So for send event, we'll instantiate a new event data, which will take in an event code and a dictionary byte and object. So the event code is a byte, so I have to cast a byte, pass in code. I don't know, my parentheses are all getting all crazy here. And then pass in parameters, and then for our send parameters, we'll just do new send parameters. The default should be fine. I do, for the send parameters, I do eventually want to, once we start, maybe start using different channels and encryption and all that fun stuff, where the send parameters are actually significant, I do want to go into our code and add the ability to add special attributes to our methods that will modify the way the send parameters are sent. But for now, we're not going to worry about that. So yeah, so send operation with response does that, or send event with response. So for our event code parameter, we don't have a system invoke ID member on that enumeration yet. So I'm just going to alt enter it in. So now we have that in our event code parameter. Okay, so now that we have that, we can now finish our, there's our code there. We can now finish inside of our server client systems. We can now finish our proxy. So instead of throwing a new not implemented exception, we're going to say transport send event with response. And then for the event code, we're going to do invoke. How about just reuse invoke method on system? That seems like a sane thing to do. And we don't have parameters. How did we do? I'm sorry for jumping around so much, but I need to know how we did that on the client side. So what do we do on the client side? If we jump in here to client systems, we pass it into the operation writer, and the operation writer, what did he do? Invoked set parameters, and what did set parameters do? It just serialized it down. Okay, See, the unfortunate thing is the proxy interceptor doesn't have access to a serializer. Nor should the proxy interceptor really have any, I guess, any concept of... Shouldn't have any concept of being able to serialize those arguments. I kind of want that to have that live somewhere else. But the only solutions I can think of aren't very pretty. We should have access to a serializer when we instantiate the proxy, though, right? Proxy, we get the client context. Yeah, you know what I'm going to do? I'm just going to put all the serialization in this code right here. This is a prime place where I would want another component in the middle to take this object array of arguments and actually turn it in and serialize it. Because as you see right here, we had this sort of lopsided abstraction where this guy, this intercept method, when he sends that event, he's not worried about how to actually send that data to Photon, whereas this will have to be. As far as the event writer, I'm not sure that we can actually... I don't think we can use the event writer, because the event writer is a object that is shared between all of the different components in this architecture. So, again, I'll just write a little bit of slightly not as pretty code as I would have liked, but I think everything will be okay. So for his constructor, we'll take in an iSerializer, and we'll alias that out into a field. Then for intercept method, what do we need to do? Well, we need to create our parameters. So var parameters equals new dictionary of byte and object. That's the first thing we need to do. And then we need to write the argument. So I'm going to say using var ms equals new memory stream. I don't like this, but again, we will fix this in a later thing. So serializer, write arguments, passing in our binary writer. For our types, it's going to simply be the method dot parameter types. And then for our arguments, we'll pass in arguments. And then we'll say parameters at byte operation. Actually, this is going to be an event. So event code parameter dot argument bytes right there equals ms2 array. And then we'll say parameters byte event code parameters dot method ID equals method dot ID. So it knows the method, it knows the argument bytes. It doesn't seem to know the component, because the component is not set for the client side, but it is set for the server side. So we'll go ahead and pass in the component too. So we'll need the component ID, obviously. Event code parameter component. Wait, how does it get the component? Is that do we just use the event code for the component ID? I wonder. I think we do. I can verify by opening up the client transport base. No, I can verify that by opening up the system's event reader. So invoke method on system. Oh, it gets client interface type ID. That's what we pass in. So client interface type ID equals method component ID. And then finally, after we do all that, we can now say transport dot send event with response. The event code is going to be evoke method on system. We'll break this out to make it a little easier to read. And the parameters will be parameters. And the on response is going to be, it takes in a code and parameters are, let's just do P or something. What variable name did I use? Code and response. Code and response, and then it simply says deferred.load, passing in our response and our serializer. Okay. So this will properly intercept a method from the master server to the region server that expects a response. And this will send it as an event invoke method on system, but it'll have a system invoke ID. So on the other end, I'm going to add in logic to understand that. But right now we're going to have an error because we added that dependency to the serializer in our client interface interceptor, but we never supplied it. So let's go ahead and do that. So this is where we instantiate our client interface interceptor, and we'll simply pass in client dot application dot serializer. And there's our serializer. Okay, so that is the modifications to our client systems on the server. So now what we need to do, now that we know that we're sending this invoke method on system, we need to do two things. First of all, in our MMO peer base, we need to add code that handles a response. So that's going to be probably from an on-operation request. So we need to handle an on-operation request that understands this. I'm thinking here. I wonder if I should have added this to the client context and not the MMO peer base. Let's actually figure that out last. Because what I want to figure out now is handling that event in our BuzzMMO server region in our master server peer. So remember, our master server peer is this massive class that's kind of a Frankenstein of a bunch of other bits of code in this code base. And what he needs to do is he needs to receive an event. So handle event, which goes down to here. And it goes into event handlers, byte code, handle code. What he needs to do is on on my systems event reader, which is all the way in the client. Here we go. Invoke method on system event. So this is the bit of code that's responsible on both the region server and the game client that receives a request from the server saying, hey, go ahead and invoke a method on one of your components. But now he needs to be a little bit more intelligent. So his invoke code right here needs to check if it's a deferred, and if it is, he needs to send in a response back to the server whenever that deferred completes. So it'll be the analog to the code that is located in client context, invoke method on system. It's basically the equivalent here. Let's move that off to the side. And I guess let's go ahead and get started. So what I'm going to do here is we get the method. So we do have the method. I'm going to say right here, after we get the system, I'm going to say if method return type equals mapped method return type dot void, then we'll simply invoke the method and return. We have nothing else to do. Otherwise, I'm basically just reading off the other side here. Deferred def equals null. And then we'll try deferred equals cast to deferred, and then we'll do method.invoke, passing in system and arguments. So note that, so indeed what we're doing here is we're invoking the method on the client, or in the region server in this case, and receiving his deferred. And then if def equals null, we'll throw an exception. New invalid operation. And we can use template strings here, because this isn't code that's being compiled right in Unity. It's being compiled by Visual Studio. So we can use some C#6 features, actually practically all of them. And I'll say method method info name on component, maybe do that, method component type name return null. All right, then I will catch an exception. Actually, RPC exceptions, they exist in BuzzMMO base, so I can catch an RPC exception. E, and in this case for E, I don't care. We need to get this done. Def equals deferred fail. E.message throw. Catch deferred equals deferred fail. There was a fatal error. Throw. And then finally, what we're going to do is do var response equals new dictionary of byte and object. And we need to pass in the system invoke ID, of course. Now, when we send this response, because we're now in client land, we need to send it as a operation request. So I'm going to send the response. I'm going to say cast a byte operation parameter dot system invoke ID equals convert to byte. Actually, we don't need to because it's going to be boxed anyway, so it doesn't matter. We need to get our parameters, and we need to get out of our parameters, cast a byte, event code parameters, system invoke ID. So this response so far will indicate to the server which response we are returning from. And then we want to say def.save, passing in our response and our serializer. And once it's saved, we'll do on success, and then we will send the operation request to the server. So, let's see here. we need to be able to send an operation request from within the system's event reader. So I think probably the best way to go about doing this would be to have the system events reader take in an iTransport. An iClient transport. I think this is the right way to go about it. Is it? iClient transport. Yeah, this is probably the only way to go about this. So we need to take in an iClient transport. And now that we have that as a dependency, we can scroll down. And then after we've saved the deferred, I can do transport, send operation, passing in an operation code of send system response. Where did that come from? Did we just create that? Operation code does not equal... in our master server peer, handle system callback. Oh, okay. Yeah, that's fine. That's fine. It's all good. And then response. Okay. Why does ReSharper really want me to remove that code, but when I do, it doesn't compile? ReSharper is really on a roll of being very unreliable these days. Anyway, I could ignore the possible null reference exception because I'm not seeing any code path that will result in a null reference exception happening there. So now we have the code on the client and the region server that will send an operation of an operation code send system response to the server. So now what we can do is, let's go ahead and hit F6. I want to compile because I know we're going to get some compiler errors because I changed the signature of that constructor. Okay, we have 3 compiler errors. Let's just go down them from tests. Okay, so tests, remember our systems event reader wants an iClient transport. So for this, we can just pass in transport directly. For our client console, our systems event writer wants a transport, so for this, we'll just pass in our transport there. And for our master server peer, our systems event reader wants a transport. And in this case, the iClient transport is itself, so we're going to pass in this. And now that should compile. We will get errors in the Unity side, but we'll fix all that up in a bit. So, blah. Okay, let's close all this nonsense. So what we've done so far is our systems event reader is now capable of sending a response in the form of an operation request. So that means in our server, on our MMO peer base, we need to handle that response. You know what I'm going to do, actually? Because our client context on operation request, invoke method on system. Okay, we're using the operation code as the component ID. Now, that's going to be unfortunate because we do need to be able to send the system response as a specific thing that is different from our component IDs. There's 2 ways we can do this. From the start, the component map I built in this reserved byte. Like, it will only generate IDs for components after a certain number, so that I could say, okay, so send system response is 1, so that means start generating IDs on ID 2. But I just came up with a much better way, and I didn't know what I didn't think of this before. I'm just going to straight up assign this to -1, or byte -1. Oh. I think I'm an idiot. Bytes are unsigned. S bytes are signed. I got mixed up because, funny thing, Photon will actually flip out if you try to use anything that's unsigned. So you can't pass in a uint to your dictionary, for example. Unity will or Photon will flip out. So that's kind of why I thought that would work, but obviously it won't. I am dumb. So now we have to come up with a different solution, and I think that solution is going to come back to our component map. So if you recall, inside of our base component map, we do have this reserved component ID limit. and it should be used. Put an ID. And then our component map binary thingy does indeed pass that along. Okay, so what I'm going to do is I'm going to go into the operation code, and I'm going to switch these. I'm going to leave set system response as 0 and init context as 1. Then, when I instantiate my component map on the master server, which should be done in my master server context, no, in server context, when I instantiate these component maps, what I want to do is instantiate them with the reserved component ID limit of 2. Or 2, I think. So 2, and then 2. Well, we don't need 2 for our actors, but we do need 2 for our region and our players. So now all of our components should start with the ID of 2. We'll verify that here in a moment. But with that out of the way, we should be able to jump into our server MMO peer base. And down here, I'm going to add another else if. I'm going to say else if operation code equals operation code dot send system response. And if it is a send system response, we're going to unpack the response that was sent by the client, and we're going to invoke that callback. So what I'm going to do is I'm going to see what we do in our systems event reader, I believe. No. It's not in the client systems. Where do we handle that? So right here we have on event, which goes into handle event. Handle event goes into handle code and parameters, which should be our systems event readers. So invoke method on system, add system. Or whoops, I'm not looking for handle event. I'm looking for operation response. That's what I'm looking for. On operation response, where are you? It says handle system callback. Handle system callback does that. So I'll move that off to the side, and we're basically going to write that in right here in our MMO peer base. So I'm going to say var method invoke ID equals cast a byte parameters or operation request. And then we can say cast a byte operation parameters system invoke ID. And then I'll do var callback equals callbacks dot get callback method invoke ID. And then callback and pass in our operation code and our operation request dot parameters. Well, that was exciting. Let's go ahead and hit F6 and see what happens. All right, let's pop down our thing here. So we got our pings and got hello from the master server, but we didn't get any response from the region server. So the first thing that I want to do is I want to verify that the region server was actually invoked. So this region def test, I will say log info dot def test from master, and then I'll hit F6, and we'll see if that pops up. So connecting to master server, awoken, got hello, got def test from master. Okay, so we did receive the result, or we did, you know what I'm saying. We did receive the request, but it doesn't seem that we sent it to the server. So if we jump into our master server peer, so we have our wait a sec, what am I doing here? So we have handle event. Handle event goes into our handler, which is our system event reader. So what we need to do is we need to set a breakpoint there, and I'm going to go ahead and say attached process. And I'm going to attach it to Photon socket server. And then I'm going to trigger a restart of one of our game servers by doing something a little dirty. I'm going to jump into... Where are you? I don't even know where you're located on my hard drive anymore. I'm going to jump into the Photon server. And then I'm going to come over here into deploy BuzzMMO game 1 bin. And I don't know, I will just delete a PDB. Whatever, don't care. That should trigger a restart, I believe. And it did not. That's unfortunate. Seems I'm only watching .config files and DLL files. So to trigger a restart, let's go ahead and just, I don't know, open up log4net.config, which I don't believe is ignored. It is the only one that's ignored. Of course it is. Let's just open up BuzzMMO server region.config, and I'm just going to make a change here. And then hit Control-S. That should trigger a restart. And it did. And check that out. Okay, so we got this. The method return type is void here, so we'll wait a second. Now we got this. Method return type is response with result. So let's see what happens here. We get the deferred. And then I'm going to go ahead and just sit here and wait for those 2 seconds to pass. And this code was not executed. That is interesting. So what I'm going to do is I'm going to trigger another restart by just adding a new line to our .config file. And then I'll wait a minute because we do need to have this thing sent. So we did get response count 1. So def save. Let's go ahead and jump into that. Come over here. Okay, so the deferred is never finished. Oh. You know what? I wonder if I never started that fiber. That would be embarrassing. I did not start the fiber. Okay. That was a stupid thing. Stupid mistake on my part. I never started the fiber, so the deferred never completed. Remember, we scheduled the deferred on that fiber. So let's go ahead and hit F6. Clear out my logs. Let's see what happens. So awoken, got hello, got def test. Coming back into this, got from region server. And it works. So yeah, we have bi-directional communication between the two servers. And again, it is just a really interesting sort of thing here where we're having the system do something it wasn't meant to do previously, but we're kind of adding this in. And I'm keeping all of this in mind as we move forward so that when we come and actually refactor our systems code so we have the same code running on the server and the client as far as this implementation, things will be a lot nicer now that we have all this stuff in mind. But the point is, we can now send deferred requests to the region server from the master server or from the master server to the region server. And that's the whole point of this video. And I suppose we'll see you guys later.